afternoon, ladies and gentlemen. My name is Adebanjo Olalekon Peter, BSc Mathematics, Obafemi Awolowo University, Ile-Ife. Bachelor of Medicine, Bachelor of Surgery, Ladoke Akintola University, Ogbomoso, in view. I'm here once again this afternoon to enlighten us a bit on derivation of equation using dimensional analysis. How we can use dimensional analysis to derive an equation. We know that we have two major uses of dimensional analysis. We can use it for correctness of equation, that is, to show that an equation is dimensionally correct, to show that an equation is consistent. And we can also use it for derivation of equation, that is, to derive an equation. Let's take for instance, we have like the period t of a simple pendulum depends on the mass m of the ball, the length L of the string, that's an inextensible string, and the acceleration due to gravity g. If k is equal to 2 pi, we want to use dimensional analysis to derive an equation showing the relationship between the variables. Now, if we need to solve this one now, you start from the equation period t depends on mass m, the period t depends on length L, and the period t depends on acceleration due to gravity. So it means that the period depends on three things: the mass, the length, and acceleration due to gravity. So this implies that t directly proportional to m, L, and g. So automatically, when we are changing this one to equality sign, we will introduce a constant. So I can have t is equal to k, m, I put x on top, L, put y on top, g, put z on top. So we need to get the value of x, y, and z for which this equation is valid. Now, if you look at it dimensionally, the dimension of period, so you know period as a unit second, dimension of period is still capital T. Dimension of mass, since the unit is in kilogram, dimension of mass is capital M. Dimension of length, since it is in meter, it is still capital L. While the dimension of g, since we know that g, our acceleration due to gravity, is meter per second square, dimension is LC minus 2. We will use each of these dimensions to represent each of them. So this implies that we have t is equal to k mx ly, instead of g it will be lt minus 2 raised to the power of z. Now from here we will have t is equal to k mx ly. We will use this to open bracket lz t minus 2z. And from here you will see that from the right hand side we have m, l, and t. From the left hand side we only have t. We can create m and l at the left hand side so that we can have something of this nature. We have m to power 0, l to power 0, then t to power 1. We know that m to power 0 is 1, l to power 0 is also 1. T raised to power 1 is t. So this 1 times 1 times t, which is still giving me t, is equals to km raised to power x, l raised to power y dot l raised to power z, then dot t raised to power minus 2z. Now, by law of indices, we can pick one of the n here. So I can have n raised to power 0, n raised to power 0, t raised to power 1 equals to k, m raised to power x, n raised to power y plus z. Law of indices, when you are multiplying, you have then t raised to power minus 2z. Now, from here, we will now equate. We will equate n to n, l to l, then t to t. So that this implies that our m raised to power 0 is m raised to power x. This implies that our x is equal to 0. We get our x. Again, our m raised to power 0 is equal to l raised to power y plus z. This implies that our y plus z is equal to 0. And this also implies that our y is equal to minus z. Y equals to minus z. Then again, our t raised to power 1 is equal to t raised to power minus 2z. From here, this implies that minus 2z is equal to 1. So z equals minus 1 over 2. Knowing fully well that our z is minus 1 over 2, we can easily replace the z here. So let's say this one is 1, this one is 2, this one is 3. I will say from 2, from y is equals to minus z. We replace z by minus r. We have y equals to minus into minus r. So y equals to r. And from here we see our s is 0, our y is r, and our z is equals to minus 1 over 2. Now, having obtained the value of x, y, and z, we have x as 0, y as 1 over 2, z as minus 1 over 2. We come back here. You replace your s, you replace your y, you replace your z. Knowing fully well that the value of k has been given to be 2 pi. We have since k is equal to 2 pi. Let's label this one as alpha. I will just say from alpha, we have our t is equal to, we replace k, 2 pi m raised to power 0, L raised to power 1 over 2, then G raised to power minus 1 over 2. From here, we will now have T is equal to 2 pi multiplied by anything raised to power 0 is 1. We have 1 times L raised to power half means square root of L multiplied by, this one will be minus becoming 1. That's 1 over square root of G. Now, by the time I rearrange this very well, I will have T is equal to 2 pi square root of L over square root of G. And looking at this implies that we can have it as 2 pi square root of L over G. This is a very common formula for period in simple harmonic motion. It is telling us that the period of a simple pendulum actually depends on the length. The higher the period, the higher the length. The lower the period, the lower the length. The period is directly proportional to the square root of length. So I can add, if we say period is directly proportional to square root of L, we can say T is equal to K root L, which means that our K is T divided by square root of L. And this implies that we have T1 over root L1 is equal to T2 over square root of L2. We can also be using this one in question solving. There are some questions whereby you will have to get any of these parameters. Maybe T1, you'll be given L1, L2, and T2. Or you won't get L1 where you are given T1, T2, and L2. Or even L2. So any one of them, we can use it. So this is a very good example of how we can use dimensional analysis to derive an equation that exists, relationship that exists between two or more variables. Thank you so much.